So 4.4 is going to be what we're rolling with today. We're going to solve exponential equations, and if we remember what an exponential equation was, if we have an equation such as 4 to the x, my variable is in the exponent, and we have to learn different methods for solving that. Is what we're going to do here. So if you look at MathXL, it says that it wants to solve the equation by expressing each side as a power of the same base and then equating exponents. I'll talk my way through that. Excel's not going to go what method you use to solve it. So I guess you're welcome to use whatever method you need to do this. Okay? Be one of those things I can't tell your work. Anyway, the first method is to get the same exponent, the same base. So I'm going to leave that as 4 to the x. And what we want to do is we want to write 256. I believe it can be rewritten with a base of 4. So I'm going to change 256 into, and since I don't know what that is, I'll just do it by hand. 4 times 4 is going to give me a 16. Times 4 again gives me a 64. Times 4 again gives me a 256. So there it is. 4 to the 1, 2, 3, and 4 power. So 4 to the 4th. So what that means is we're going to solve this and say x is equal to 4. Okay. Now I said there are multiple ways to solve this. Excel is not going to go which way you went. So here we're going to do it a different way. We're going to go 4 to the x is equal to 256. Okay. And we can actually solve this by taking a logarithm. So there's a couple different ways we can do this. First way is I'm just going to convert into logarithmic form. So again, we're going to go around start at my base, go around, and that gives it to me. I can change that into the log. Base 4 of 256 is equal to x. And then I can run to my calculator. We can go into math. We can arrow up to log base, and we can choose log base, and this was log base 4 of 256. And we came home with x equals 4 again. Okay? And this is the way that we need to learn how, because we're going to have to solve equations later. Another way, if I have 4 to the x is equal to 256, okay, what I'm going to do is I'm going to take the natural log of both sides. Okay, that allows me to solve that equation. And the process is, since I made both sides a natural logarithm, I did the same thing to both sides. I haven't done anything bad at all. But now, since this is a logarithm, we can take this exponent and we can wheel it up front. So this becomes x times the natural log of 4 equals a natural log of 256. So to get x by itself, we're going to divide out the natural log of 4. So if I come into my calculator again, and I run with the natural log of 256 divided by, and make sure we get that parenthesis to close it off, but we have the natural log of 4, we get the same answer, x equals 4. So again, we solved the same problem in 4 different ways. Excel is wanting you to do this way, but again, it's not going to know which way you did. Okay. So we'll just leave it at that. And I just took 3 minutes and 23 seconds to explain a problem that I didn't need to go that deep into. All right, so number 2. 6 to the x power is equal to 1,296. Okay. Now I'm going to leave it alone. You guys can do it from here as far as what method you're doing, but I'm going to follow the directions in Excel just to give us that chance. And again, this one's simplifying into logarithmic form is pretty easy, but 6 to the x is equal to, I have to figure out what power of 6 that is, because this is essentially do it by hand. 36, we're going to take that times 6 to get 36 carry the 3, 18, 216. We're going to take that times 6 again. That's going to give me a 36 carry the 3, and 6 and 9, and then 12. So there it is. 1296 is 1, 2, 3, and 4. So 6 to the 4th. So that means that x has to be 4. Okay. That was the way that Excel wanted us to do this. Again, it probably would have been easier if we had just gone to log base 6 of 1,296 is equal to x, and then and use the log base on our calculator. And that's why we had a calculator and a non-calculator part to this test back in the classroom. So I guess we can appreciate not having that to solve. However, this is where it becomes, when it's simple like that, the logarithm, that is a nice saving grace when we move on to the next problem. we're going to have a little bit of a, no, I would say an issue, but I mean, no, it's not really an issue at all. It is just strictly, it involves more work. Okay, so I know I can go with 6 to the 2x minus 4. I know is the same thing as 6 squared is 36. Since they have the same bases of 6, I know that 2x minus 4 has to equal 2. So 2x has to equal 6, and x has to equal 3. Okay? And again, just to show you it goes the other way, we just have to work a little bit more, a little bit harder. Log base 6 of 36 is equal to 2x minus 4. Okay? So it works the same way. What is log base 6 of 36? 6 what power is 36? 2. And you know what? We're solving the same exact equation over here. Okay, so again, it's however you want to get there. I'm going to stop doing it both ways. That's the way Excel wanted us to do it. Okay? 4. 8x to the, 8 to the x power equals 16. Again, it's asking us to raise each side. Again, 8 to some, I'm going to do this one with exponents. Again, it just kind of helps us review some of those math things that we did. 8 to the second power is going to give me 64, so we're going well past 16. So this is a problem where we're going to actually change both sides. 8 is 2 to the third power. And this allows us a chance to review some exponent rules. When I have a power to a power, I'm going to multiply. So 8 was 2 to the third. And because I'm raising that to the x power, this becomes 2 to the 3x. 16 is 2 to the fourth power. So that means that since we have the basis of 2, I know that 3x is equal to 4, and that means that x is going to be equal to 4/3. And again, if we're talking about solving equations, well, let's just talk about this. Let's go the other way. This would be the log base 8 of 16 is equal to x. Again, no way I can do that in my head. However, if I run out to my calculator can shove me an answer that's 4/3, which is going to be 1.333 that we need to convert. So we'll just leave it at that. Okay, 5. We're still doing that same base thing. So I probably gave you way too many of those. 16 to the x is equal to 64. And again, we're stuck with that problem. 16 to the first is 16. 16 squared is 256. Well past 64. So I've got to break down both sides. Okay. 16 is 2 to the fourth power. And we're going to write that. So that means that's going to be 2 to the 4x. 64. I know that 2, again, is writing this out. 2 times 2 times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. So there's where I needed. That was 1, 2, 3, 4, 5, 6. So 4x has to equal 6 since those bases are equal. And that means x is equal to 6/4 or 3/2. Okay? Again, take it or leave it as far as being able to use the same base for that. Okay? Again, we're still doing the same exact stuff, but I guess I like to do these just because it helps us remember our exponent rules a little bit. This is 2 to the x minus 3 is equal to 1/8. Okay, again, so we're going to have a base of 2. I can guarantee that because that's what's over here. So I need to change 1/8 into a base of 2. So to get 2 to become 8, I know 2 squared is 4. 2 to the third power is 8. So I know it's going to be 3. But 2 to the third power is 8. I need it to be 1/8. So we're going to put a negative sign in front of it. And now we have both sides are a power of 2. So that means that x minus 3 is equal to a negative 3. We're going to add that 3 over and get a 0 for the solution for that. Okay? And these are all exponential equations. We're not going to have any domain restrictions to watch out for. So we can just keep on rolling. When we get ready to solve logarithmic equations here in a little bit, we're going to have to watch out for domain restrictions on that. But that took care of the first 6. So, and we're 9 minutes in, so maybe we won't be a 45-minute lecture after all. All right, so solve the exponential equation. Okay, so here's what and this is the problem here. 10 to the x is equal to 2.32. Okay. Now the deal here is it wants us to express this in terms of natural logs. Okay. And so what we're going to have to do is, it's the natural logs. Yes, natural logs. So we're going to have to do this is where we're going to do the other method. So we're going to natural log both sides. We're going to do the natural log of 10 to the x, the natural log of 2.32. So we're going to write this as x times the natural log of 10 equals the natural log of 2.32. So that's all we did. We took the natural log of both sides. Because it's a natural log, we can take the exponent and we can write it in front. And now we can get that x all by itself by writing the natural log of 10. And here's the unfortunate, I won't say it's unfortunate, but Excel is going to want two answers here. One answer is in the form of logarithms, so we're going to have that as one answer. And then we have to go to our calculator and we have to type in the natural log of 2.32, make sure we close that off, divided by the natural log of 10. To get, what are we supposed to round this to? Use integers or decimals. Oh, it doesn't say. Oh, because the question is still asking you for the natural log answer. So it's still asking me for this. I don't want to take time to type it in, but when you get to the decimal part, it's going to say, round it to 4 decimal places. Maybe. I don't know what it was, but I will round it off to 4 decimal places. Okay, but that's what we're going to be able to do. Excuse me. Okay. Again, if we were doing a log-based thing, if we could write it in the form of common logs, just to show what we could do here. No, I'm not even bother. Nope, not gonna do it. Okay. Here it is, e to the x. This is why we're going to use natural logarithms here, just because we're going to use some problems that involve a base of e. So because it's involved a base of e, we're going to take the natural log of both sides. So we're going to natural log both sides. Again, the whole purpose of natural logging is that we can move this down. So this is x times the natural log of e equals the natural log of 4.1. Now here's another case of I should have hit this earlier and I missed it. We need to know what the natural log of e is. The natural log of e is going to be some value that we should automatically know. Just to refresh our memory, a natural log is a normal log of base e. So in reality, this is the log base e of e. So what power am I going to raise e to get e? Well, that's 1. Okay, so the natural log of e is going to equal 1. So really, I'm done. X equals the natural log of 4.1. So I'm going to type that in as one answer, and then I'm going to roll to my calculator, and I'm going to type in the natural log of 4.1. Okay, and that's going to give me my decimal equivalent. Okay, so that's what we're needing to be able to do. So rolling on to number 9. It's another similar problem. We have 7x is equal to 12. Okay, and again, it wants a solution set. In reality, what we could do is we could go with log base 7 of 12 is equal to x, and I could go to my calculator and I could get an answer and I could be done. However, MathXL wants your answer in form of natural logarithms. So again, we have to natural log both sides. We're going to move that variable in front. So we have x times the natural log of 7 equals the natural log of 12. We're going to divide out the natural log of 7. So there it is. There's one answer. And then we got to drop that into my calculator and figure out what the decimal equivalent is, or I've got to do this in my calculator and figure out what the decimal equivalent is, but it's going to be the same. Okay? So again, that's a little cumbersome, but that's how Excel rolls. So we just have to deal with it. And now it's just going to be different variations of different types of exponential equations that we need to solve. Okay, so there's number 10. Again, it's 2 parts to this. They want the solution set in the term of natural logs, and then a solution into the actual decimal equivalent. Now, before we go natural logging, being a lumberjack and logging both sides, we're going to divide by 6 to get that all by itself. So we have e to the 3x, and then we're going to divide that by 6. 6 goes into 9 once with 3 left over. 6 goes into 36 twice. 6 goes into 36 6 times. 6 goes into 6 once. And because I feel like I botched that, we're going to verify. 966 divided by 6 is an error because I got some other junk in there. Try that. 161. All right, I got it right. All right, where was I at? Anyway, here we are. We're ready to natural log both sides. Again, the whole purpose of natural logging is that I can pull that exponent out front. So 3x times the natural log of e equals the natural log of 161. The natural log of e is lovely because it disappears to 1. We're going to divide the 3 out of there, and I'm going to find out that x is equal to, there's my natural log answer, and then I'll have to find out what that decimal equivalent is to know what comes next. Okay, 11. Okay, and here is where, maybe if we were doing this as we're doing this with regular logs, that actually go much faster if all we did was convert form. Okay, but we're not converting form. We're learning how to work with an exponential equation. So again, we're going to take the natural log of both sides. So we're going to go with x plus 3 is the natural log of 2. That'll be the natural log of 421. So again, this one is going to be looking a little funny. We could distribute this to get rid of the parentheses, but I'm not going to do that. I'm just going to divide the natural log of 2 out of there. And so we have x plus 3 is equal to the natural log of 421 divided by the natural log of 2. And now to get x by itself, we're going to subtract the 3 over. So there is answer number 1. It's my answer in the terms of natural logarithms. I'm going to have to get that into my calculator so that we can figure out what the decimal equivalent is. All right, the halfway point. And we're 17 minutes in, so maybe this won't be a 45-minute lecture. Here we go. Log base 4. So now we're going to go the other way. Log base 4 of x equals 2. Okay? Again, there's a couple of different thoughts to doing logarithmic problems. I struggle with which way to go with it, depending on the year that I'm doing it. We could change this to exponentials. Okay? Meaning this is 4 squared is equal to x, so 4 squared is 16. So I know in this case, x is equal to 16. Okay? The other way to look at this problem is this. We're going to do it in the form of inverse equations as far as the exponential. I'm going to take, since it has a base of 4, I'm going to take each side to be a power of 4. Those are inverses of each other, so this becomes x equals 4 squared. So that is 16. And we get to the same answer either way. But so if I refer to exponentiating each side, here is exponentiating each side. If we convert form, we're just converting form. I usually exponentiate each side, but I found that in the past, just because an old calculus teacher said we need to do this, so that's what I did. However, student-wise, I think you guys grasp the change of form easier, and we roll with that. And so I will give both answers and let you decide what you think is best. All right. Next. The natural log of x is equal to 2. Again, if we are changing forms on this, what number are we doing? I'm lost. We know that a natural log is a base of e, so this is going to be e squared is equal to x. If we're changing forms, we'll change forms and we're done. Okay? If we're going the other way, I know that e has the natural log of has a base of e, so we're going to exponentiate both sides. Those are going to cancel, and we have e squared this way too. So in both cases, we got to e squared relatively quickly. If we look above our natural log button, and I don't know if I can slide this and you can see a natural log at all, but here's our natural log button right here, the ln. Above my natural log is that e to the x, so we're going to hit second, e to the x, and then what power? 2. So there we go. E squared is 7.3891. So again, it wants it in exact terms of e, and then it's going to want a decimal equivalent. So it's going to have the exact term. It's going to have e squared for one answer, and then we're going to have the other one. Okay. All right. So rolling on to 14. Good night, sister. All right, log base 3 of x plus 8 equals 4. Hey, get out of here. All right, sorry. The dog was needing to be expelled from my lair. Okay. So again, this is going to be how you prefer to look at it, but it's going to work the same way in the fact that we're going to exponentiate each side of both sides. Whatever we're going to do with that. Sorry, let's try again. Again, if you prefer to change forms into exponential, you can roll with it. 3 to the 4th power is equal to that. I'm going to exponentiate each side, so those are going to cancel, so that means that x plus 8 is equal to 3 to the 4th. I have to know what 3 to the 4th power is. It is 81. We're going to subtract the 8 over and get a 73. Okay? Now, I have done a horrible job here because I just realized that the last 3 problems have been logarithmic problems, and logarithms have domain restrictions because we cannot take the logarithm of a negative number. Now, we've lucked out in the fact that I haven't had any values that cause us to have an error. For example, if we had negative 8, we'd have been out of luck here. We could not have done that problem, or anything left of negative 8 would have caused this to be a non-real answer. Okay, we got 73, which wasn't a big deal. Okay, but remember with logarithms, we've got to be checking for that extraneous solution. Okay, or that as far as that goes. Okay, again, just more of the same. Log base 2 of x plus 19 equals 5. So again, I'm going to exponentiate each side. We're going to make each side to be a power of 2. Those are going to cancel, so that means that x plus 19 equals 2 to the 5th. 2 to the 5th power is 32. We're going to subtract that 19 over and get 13. Okay? All right. 16. Rolling with the same stuff. Again, so if, again, 13, if we put 13 in for x, we're going to get a positive number there. Everything's good. We didn't have an issue with a extraneous solution. This one's a log base 3 of x minus 4 equals negative 2. And again, this one rolls the same exact way. This would just have to work with fractions. Exponentiate each side, so that means that x minus 4 is going to equal whatever 3 to the negative 2nd power is, which is negative, 1/9. So we're going to add that 4 over there to get 4 1/9. Okay. All right, see if we can get into something different here. I may start just skipping questions if these are all working the same exact way. Okay. This one actually has there we go. So when we solve through these, when we got to the logarithms, there's actually a spot where there is no solution. So we just have to make sure that we're paying attention to that. I'll go ahead and do this one just because we're starting to get into something different. As far as we are looking at doing a little bit more work on the front end. On all the other ones, the logarithm were already isolated. Log by itself, log by itself, log by itself, natural log by itself. That all was there. That's not the case in this one. So step number 1 is we're going to subtract this 9 over. So we have 63 times the natural log of x is equal to negative 7. And so we're going to get this log all by itself. So we're going to divide by the 63. And so we get the natural log of x is equal to negative 7/63. And here again, we have to know we have a base of e, so we're going to exponentiate both sides. And we can actually, the answer, I think we have to have exact form. Type an exact answer. Yes, we do. So a to the negative 7/63. That is going to be my exact answer. And the next part of it's going to ask me for the decimal equivalent. Okay, so again, it's worked exactly the same. We just had to do a little bit more work on the front end. Okay, all right, so again, we're just going to start increasing the complexity of these logarithm problems because now we're going to have to do some condensing first. Okay, so what happens is before I can go about any of this exponentiating or converting forms, I can only work with one logarithm. So we're going to have to condense this. So this becomes log base 6. So now we're going to go back to the condensing rules. If my tongue and teeth would work together. We're adding those logarithms, which means we're going to be multiplying x times 5x minus 1 is equal to 1. Okay, so now we're back to what we were doing. It just looks a little bit different because we have a product there. But now it's going to be exactly the same. I'm going to exponentiate each side. So that means that x times 5x minus 1 is going to equal 6 to the first power, which is 6. Okay, so we're solving this equation. 5x squared minus x equals 6. I have x squared and I have x in the same problem, which requires me to use my favorite F word, which is factor. Okay, so I know I'm going to have to use 5x and x. I can use 1 and 6. I can use 2 and 3. I say we have to use 1 and 6 because I'm going to put the negative 6 there and I'm going to put the positive 1 there. So negative 6 times 1 gives me the negative 6. But I have a 5x on the outside. I have a negative 6x on the inside. And so that would give me a negative x. So it has been factored correctly. I could add the 6 over and divide by 5. I could subtract the 1 over. So I end up with two different answers, 6/5 and negative 1. But here's where we have to pay attention to what we got going on here. Because if I take this negative 1 here and I put it up in here for this x, I cannot take the log base 6 of negative 1. So we have to vote this guy off the island. And my only answer then is going to be 6/5. Okay, so that one had it had an extraneous answer and it had a real answer. Okay, so that's where we have to leave that one. All right, new sheet of paper. 19. All right, 6 more problems. Here we go. 19 is, we got the log base 3 of x plus 19. We're going to add that to log base 3 of x minus 7. And we're going to set that equal to 3. Okay, so this works exactly like the last problem did. We have to condense some logarithms first. We're going to write this as 1 logarithm of base 3. Okay, except in this case, my product is going to be x plus 19 times x minus 7, and that is equal to 3. Okay, so again, exponentiating each side, 3 and a 3. So that means that we have this product. So I'm going to go ahead and do a couple of steps right here. I exponentiated each side, so that cancels out. 3 to the third power is going to be 27. Okay, so what we need here is we need this FOILed out. So x times x is x squared. If I multiply the inside together, that gives me a 19x. If I multiply the outside together, that gives me a negative 7x. So that means I'm going to have a positive 12x. And then we got to know what 19 times 7 is. And that is going to be a negative 133. Okay? And again, we know how to solve these. We did this back in chapter 2. We're going to solve a quadratic equation. I'm going to subtract the 27 over. So we have x squared plus 12x minus 150. How about 160 equals 0? Okay, when I subtract that 27 over there. So we have to find factors of 160 that are 12 apart. Wow. They're not flowing to me off the top of my head. However, I bet 8 and 20 take care of that pretty good. All right, so here we go. X and X. I want to go with a positive 20 and a negative 8. Because 20 times 8 gives me the 160. I've taken care of that part. I get a 20x and a negative 8x. That gives me a 12x. We've taken care of that part. So that means I get negative 20 and I get a positive 8. Now, anytime I get a negative number, okay, That should raise a red flag. Okay? If I run this back up in here, negative 20 plus 19 gives me a negative 1. That's going to shoot me down with a ball of fire. So it is not included. Okay? 8. How does 8 do me? 8 plus 19 is going to give me a 27. 8 minus 7 is 1. Hey, it's good. There we go. 8's my answer. Okay? All right. 20. Two. Log base 2 of x plus 2 equals log base 2 of 4 plus 2. Wow. We got logarithms on both sides. Oh, what should we do with this? All right, so because I've got logarithms on both sides, I'm going to have to get them condensed. So to get them condensed, they need to be on the same side. I mean, there's actually multiple ways we can go about doing this, but we're just going to try to condense it. So we're going to write this. We're going to add that extra step. We're going to subtract the log base 2 of 4 over. Wrong. We're going to start again. Okay. Well, we can do this from here. Sorry, I wasn't paying attention to this. All right, so we're going to scratch this out. I apologize, but I'm 31 minutes into this video. I'm not about to redo it. So here's what we're going to do instead on this one. We're going to look at this guy right here. Typically, we'd have to condense it by moving it to the other side. However, I'm looking at the log base 2 of 4. What kind of power can I raise 2 to get 4? Well, that would be 2. This is a 2. So now this becomes 2 log base 2 of x plus 2 equals 4. Okay? So that saved us working with multiple logarithms just by noticing that. Okay? So now we are going to then we have to get this by itself. So in order to get this by itself, we're going to divide that 2 over. So now we're talking about the log base 2 of x plus 2 equaling 2. And now the logarithm is isolated and we can work with it. Okay? So it's, again, your preference. You could turn it into exponential form. We could raise each side to be a power of 2. So that means that x plus 2, I have no idea right or why I wrote the parentheses. That's going to equal 4. So x equals 2 when I subtract that across there. And that looks like it's going to, variable-wise, we're going to be okay with that. So that's all there was to that. Okay? 21. Okay, here we go. We're going to work with logarithms on both sides. Okay. So again, now in this case though, I don't want to get all the logarithms on one side and then set it equal to 0. Yes, I could work with that. We could end up with the right answer. However, what I want to do this time is I want to have a logarithm on both sides. I'm just going to condense the right side. If I'm adding those together, I'm going to multiply the parts. So this is going to be 10x. Okay, and now the thing is I could exponentiate both sides if I wanted to. Meaning this has a base of 10. So we could raise each side to be a power of 10, and those both are going to cancel. Or we can look at it like this. If I have a log of x plus 10 and a log of 10x, for those to be equal, their parts have to be equal, so we can just jump straight to x plus 10 is equal to 10x. Okay, so that's what we're going to do. If we can get a log on both sides, we can just set their parts equal. Okay, so that means I'm going to subtract the x over to get a 9x. We're going to divide that 9 out of there and get x is equal to 10 ninths. And we're all better people. Okay, we're getting down there. Okay, we're going to do some application problems now. So we got 3 problems left, which I think are all applications. So here's 22. Okay, we have an equation A is equal to 19.6 e to the 0.0138 t power. And this is going to model the population of a U.S. state A in millions T years after 2000. Okay, So A is going to be the population of a state that is T years after 2000. Okay, so we have two questions here. One is the population in 2000. So if T represents the years since 2000, that means that 2000 is 0 years since 2000, so we're going to put a 0 in for this. Okay, so and in reality, we could just jump straight to that because that's my beginning amount, right? If we go back to, this is going to be, this is our, I'll scroll down here. This is an exponential growth model. Could be decay, I guess. If my K value is negative, but that's my exponential growth. We need to be growth / decay model. Man, I'm an idiot. Okay, growth / decay. Okay, that is that model. So if I look at A sub naught is going to be the original amount. That's what that naught stands for. So this is the amount of population. So this number here is my original amount. Now, if we go back to, if we forgot that fact, it doesn't matter. I know that T is going to equal 0 in the year 2000. So that means that I'm going to put a 0 in for T, which is going to cause this to go to 0. I'm going to have e to the 0 power, which is anything to the 0 power is 1, and so that leaves me with 19.6. So my answer here in part A is 19.6, the original amount. Okay, that's going to be the easy part to this problem. Okay, the harder part to this problem is, when will the population of this state become 25.9 million? Okay? Now this goes, it flies into the face of what we just got doing. We're going to solve an exponential equation. So in order to solve that exponential equation, we're going to divide over the 19.6, divide over the 19.6. Okay? We're going to end up with some decimal. Excuse me. I'm going to leave this as a fraction, just because I want to have an exact answer later. Okay? This is going to be e to the 0.0138 t power. Okay? Now I have to remember that I have an exponential model here. To do that exponential model, we are going to then take the natural log of both sides. We're going to natural log that. Because it is a natural log, we can now move the 0.0138 t down. So we took this and we moved it in front of the natural log of e. The natural log of e is a lovely thing because it disappears and goes to 1. So in reality here, we just have to divide by pi. Oh my gosh, 0.0138. So here is, and I don't think we have to put it in terms of logarithms anymore. No, it just asks, yeah. No, we just have to know what is this decimal value. So we're going to go to our calculator. We're going to tip it up. We've got the natural log of 25.9 divided by 19.6. And then we're going to divide this by a 0.0138. And we get 4.56 years. So t equals 4.56. What's it asking me for, though? It's asking me for when will the population be. So that means in the year 2005, I believe is what we're going to have to do. We're going to go ahead and type this answer in there. That way I feel like I can give you a better idea of what we're going to, if we have to round that. I'm pretty sure we have to round that year up. But we will see. It tells me round down to the nearest year. So the population will be, so that means that we're going to round that down to 2004. So that means that we're going to type in the year 2004. No. Where have I gone wrong? Okay, somebody's gonna help me. Where did I go wrong? Did I copy the problem down wrong? 0.0138. That's right. 19.6. That is right. When's the population going to be 25.9? That part's right. So did I type something into my calculator wrong? So we'll break that down in case I wasn't. I should get the same answer. The natural log of 25.9 divided by 19.6 is 0.27. We're going to divide that by 0.0138. Huh. Oh. I see. So that, again, me paying attention to detail, I didn't. Oops, no. Back up. I don't know why I'm trying to explain what I did wrong here. But if I go back to this one, it's just I goofed up because I went ahead and put this parenthesis here, and I didn't need it, and therefore it divided everything out. So we're going to delete that parenthesis there, and now we're going to get that same 20.19. So that was just me entering it in my calculator incorrectly, which is silly. We're going to round down, so that means that has to be the year 2020. So this year, how about that? 2020. Oh my gosh, it is late. Not really. Just getting old. Can't do this late night stuff. You know, it is 9:23. There you go. All right, so wow, this is a one-step problem. So again, it gives me that compound interest. We worked with the compound interest formula way back in the first one. So 1 plus r over n to the n t power. So in 23, ask us to work with this baby again. Okay, so it's going to ask us. It's going to give us information here. So I know that this is going to be 11,000 is my initial amount. I want to find out how long will it be till I get to 17,000. So I'm just going to take my graduation money at 11,000. I'm going to drop it into account, and I am going to draw. Wow, I'm drawing very good on this account, 0.575. And it looks like we're going to compound it. How often? We're going to compound it twice a year. So I need to find out when I will have $17,000. So there's my equation. I've got to be able to do this. This is going to be a test type question. You will definitely see this. So in order to do this, we're going to divide that 11,000 out of there. So whatever 17/11 is, again, the more exact we can make this, the better off we're going to be. So I'm going to leave that as 17/11. I will probably put this decimal in here as long as I can possibly make it, or I'll try to leave it in my calculator and just write down something different. But we're going to take 0.0575 divided by 2 and then add that to 1. Oh, that's doable. So this is 1.02875 all to the 2t power. And now I'm ready to roll. I'm ready to use natural logarithms, whatever I want to do. It's your preference. I'm just so ingrained in the habit of using natural logs. That's what I'm going to do. I'm going to take a natural log of 17/11 is equal to 2t times a natural log of 1.02875. So that did a couple things at the same time. We natural logged both sides, but in the process of natural logging, we slid this down as a coefficient. So now to get this all by itself, we're going to divide over a 2. And we got to divide over this natural log of whatever number this is. So that's what we have to get into our calculator, and we'll see if we can do it right this time. So we have the natural log of 17 divided by 11. That looks good. We're going to divide this by, I made a parenthesis, we're going to have a 2. We're going to have a natural log of 1.0 here. There's 0 sense in doing this. Because that's my previous answer, I'm going to go second and negative sign my previous answer. Boom. 7.68 years. Round, do not round until the final answer. When you do, round to 1 decimal place. So I'm going to enter 7.7, and if I'm wrong, I will cry. Not really. But I didn't miss it, so we'd never find out if I would. And lastly, it's the same exact problem, just with different amounts. So now that you've lost that 45 minutes, I was afraid of when I started, this would be a 45-minute lecture. So, all right, the truth came out. Anyway, we're going to leave it here. Have a great day.